In triangle ABC above, what is the length of AD? Okay, so first off, let's measure a couple angles. So we have a 90-degree angle right here. Angle BDC is 90, and angle BCD is 60, right? And so because of that, we can label the last angle because we know there's 180 degrees in a triangle. So if we have two angles, then we can find the angle of the last one. So 180 minus 90 is 90, and then 90 minus 60 is 30 degrees. So we can say this is 30 degrees. And it works out nicely, right? So now we have this is 30 degrees, this is 30 degrees. And so we can see that both of these triangles in triangle ABC is a special right triangle. That is the 30, 60, 90. So this right here will also be 60 degrees. If you want to infer that, you can see that this altitude also splits this down. So this would be 90 degrees. And so you can do the same thing that we did before to find the 30-degree angle of ABC. Okay, so now we need to find the length of AD. And how do we do that? Well, there's a couple approaches we can do. First off, we will have to chronologically, in the way we solve this, is call triangle ABD congruent to triangle BDC by the AAS, right? So they share two angles, and then BD is the shared side there. And so now we know they're congruent. But now we need to employ the special right triangle properties. So we have here, let's call this 30, let's call this 90, and let's call this 60. So this is given on the reference table, but it's just helpful to memorize this. So the side length, at least for the legs, the leg that is opposite of the greatest angle here is going to be the greater value. So for a 30, 60, 90 triangle, that is going to be x square root 3. And then the one opposite of 30 degrees is just x. And then we have our hypotenuse thing opposite of 90 degrees is going to be 2x. And so we look in our case here, we can see that BC is clearly the hypotenuse, right? So we have a hypotenuse value of 12. And so we can set this equal to 12 equals 2x. We can find that x equals 6, okay? This will be useful later on when we're solving for AD. So now we just look at, what angle is across from AD. We see 30 degrees here is opposite of side length AD. If we look in our special right triangle, 30 degrees, opposite, that's a value of x. And x we already solved for 6, therefore B is our answer.